I am Anil Kumar. Welcome to my series on calculus. We'll discuss an application question based on related rates. A weather balloon with radius 9 meters springs a leak, losing air at 171 pi meter cube per minute. Find the rate of decrease of the radius after 4 minutes. Now, in such questions, we are not directly given what is the radius when we need to find the rate of change of radius. So you need to figure out that radius, and that makes these questions slightly tricky, right? So let's work on this. We will assume that the balloon itself is a sphere, right, of radius r. Now, in that case, we have volume of the balloon will be written by the formula 4 by 3 pi r cube, right? Now we are saying that the weather balloon with radius 9 meters springs a leak. So initially, the volume is with radius of 9. So we say V1 in initial volume is 4 over 3 pi 9 cube. Right, that's the initial volume. Losing air at 171 pi meter cube per minute. So that much volume is lost every minute. So we can find the volume after 4 minutes, right? So that means the volume after 4 minutes, let's say V4, right? So initial we'll write 0, starting with. Now after 4 minutes, it is losing how much volume? 171 pi meter cube, right? Per minute. So initial volume V0 minus how much it has lost, right? So it has lost 4 times 171 pi. So that becomes the volume after 4 minutes, right? So starting with whatever value, and then that becomes the loss. Right? So now let's calculate the values concerned. So we have 9 cube. We'll write it in pi itself since we have pi here, times 4 divided by 3, and that gives us 972. So this was 972 for us, and pi. Now what we have here is 972 pi minus, so we'll take away from this 4 times 171, and that gives you 288. So which is 288 pi, right? So we just took away from it, multiply by 4, 4 times 4, 4, 7, 28, 2, 684, right? So when we did this, what we got was 288 pi. So that is the volume after 4 minutes, right? Now when the volume is 288 pi, in that case, we need to find what is the radius of this balloon. So we can actually equate with the formula itself, which is 288 pi equals to volume formula is 4 by 3 pi. So r cube, and this r is the reduced r, right? So after 4. So we're just writing the small 4, saying at 4 minutes. Okay. So solving, we can get the value of r. So we can cross multiply. So we get 288 times 3 by 4 and then cube root to get the value of r, correct? So let's do that. So we already have 288. We'll multiply this by 3, divide by 4. And whatever we get, we'll do cube root, that is the power as 1 divided by 3, right? And this is 6 for us. So we get this r value as 6. So all this calculation indicates that after 4 minutes, radius equals to 6, correct? So I hope this part is absolutely clear to you. We started with the formula of this sphere, which is 4 by 3 pi r cube. Initial volume is with r equals to 9 and came to 972 pi. Then every minute it is losing 171 pi meter cube per minute multiplied by 4, we know how much the volume has reduced by, and the reduced volume is 288 pi. Again, using the same formula, we found the radius for the reduced volume, right? So we found that smaller radius is 6 for us, right? So that became 6, correct? So we started with 9, now the radius is 6. Now, let's solve the question further. It says, find the rate of decrease in radius after 4 minutes. So after 4 minutes, now we can say volume again is 4 by 3 pi r cube. Now we can differentiate with respect to time, right? So we get dv dt equals to 4 by 3 pi, differentiating we get 3 times r square dr dt, correct? Differentiating with respect to time. Now we need to find dr dt when r is 6 now, right? That is after 4 minutes. So since we have learned that after 4 minutes, r equals to 6, right? So we'll find what is dr dt when r equals to 6, correct? So that is what we'll do. So let's rearrange and we can say that dr dt is equal to dv dt times 3 over 4. We can cancel this also, right? So no need to write 3 here. So we can say pi, so dv dt, and this 3 and 3 cancel, so 4 pi come in the denominator, 4 pi, right? 1 over 4 pi times 1 over r square. So that becomes the expression for dr dt. So let's figure this out. Now dv dt is given to us 171 pi. So we are given that dv dt is constant and it is equal to 171 pi and should be taken as negative since it is losing air, correct? So we'll take a negative value of this. So we get negative 171 pi, right, times 1 over 4 pi times 1 over 6 squared, since r is 6. So we are finding dr dt when r equals to 6. Is that clear to you? Now pi and pi cancel and we can do the calculation to find the answer. Clear? So, and the negative indicates that it is reducing. 171 divided by 4 and then we'll divide by 36 also. And what we get here is 19 by 16 with a negative sign. In decimals, it is 1.1875. Right, so meters per minute. So rate of change of the radius with time will be this number, which is 1.1875 meters per minute. Is that clear to you? And since it is negative, it is reducing. So our answer is, when we write the answer as rate decreasing, so it is decreasing at the rate of, we don't have to write the negative, right? You can write 19 over 16 or 1.1875 meters per minute, right? Including units is very important in your answer. I hope that makes sense. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for